Hello and welcome to the second lesson, the introduction to quadratics and key features. In this lesson we're going to introduce you to quadratics, which is a big portion of what secondary math 2 is all about. And then talk about some key features. We'll talk about why these features are important, why we learn them, and as the year goes on and these lessons go on, we'll talk about each one of them probably again and learn how to find these features based off an equation. So let's get going. So by the end of this lesson you should be able to identify a quadratic by its equation and graphically, and its graph there. We're going to be able to identify key features of quadratics, such as their intercepts, their intervals. You'll be able to understand when the function is increasing and decreasing. Understand if the function is positive and negative. We will learn how to find relative minimums and maximums. Be able to find the symmetry in the equation, and also understand end behavior. And we'll talk about each of these in more detail. Alright, so what is a quadratic? Simply, a quadratic is a polynomial equation with degree 2. So it's something, so it's any number raised to the second power. You're going to see it a lot as x squared, as you see right here, which is its parent function. So there can be numbers in front, behind. You can be multiplying, adding, and subtracting from the squared variable. So the key thing here when we see a quadratic is I have a variable that's squared. So my variable is x, and 2 is in the exponent. So graphically, a quadratic looks like a U. I like to think about it as a smiley face or a frowny face, and we call this a parabola. Parabola is one of my favorite words. Just sounds funny coming out of your mouth. So we're going to be talking a lot about parabolas. This is what I'm talking about when I say a quadratic or a parabola. Quadratic we usually talk about as the function part, the equation part of a parabola, and the parabola is the graph part. Okay, so maximums and minimums. So all quadratics will have exactly one maximum or minimum point. So maximum point should be what's the biggest point here. We see it. Okay, if it was flipped upside down, I'd have a minimum point. It would be that bottom point. Okay. So the coordinate point that designates the maximum or minimum point on the parabola is called the vertex. So this point right here, that would be my vertex of the parabola. Vertex points are really important. You're going to see as we continue on with this lesson that vertex tells me a whole lot of things about what's happening. It's a good middle point. Alright. So we read a graph just like we read a book. We read it from left to right. If a graph is going upwards to the right, then we call the graph increasing during that interval. So really what we're saying is when I move to the right, where is it increasing? Where does it start increasing? And the graph is going down as we move to the right, then we call the graph decreasing during the interval. I like to think about this as if I have a little person, okay, and they're starting to walk. Are they walking up a hill, or are they going to walk down a hill? If they're going to be walking up a hill, we're going to say that is increasing. If they're going to be walking down the hill, we're going to say that's decreasing. I don't know what that G is. We're not decreasing today. We are decreasing. Okay. So if a graph is increasing as we move to the right, we will have a minimum, and if it is decreasing as we move to the right, we will have a maximum. So let's look right here. We're going to break down some colors here. Notice that this first part, as I'm moving down, if I have a little person here, as I move to the right, notice I would be going downhill until I got to this point right here. What did we call this point again? We called it the vertex. So it'd be decreasing to right there, but then all of a sudden, at that point, they start going up the hill again. So that vertex is going to split when that function is decreasing and when it is increasing. And let's do an example here. So example, finding intervals. So find the interval on the graph where it's increasing and decreasing. Okay, so when we are talking about intervals, we are talking about x-axis quantities. So we are going to use my numbers on my x-axis, so that axis in green, to describe what's happening with the y. So when I want to talk about when is it increasing, I'm saying where am I going uphill? I have my little person here at the beginning, and I notice that I'm going to have to walk uphill until I get to that vertex point. So whenever we're doing an interval, we want to do the smallest value of that interval. So in this case, if we notice that there is an arrow right here, we notice that it's going to continue on downwards. So my farthest left point is actually when x is negative infinity, because we're going to keep going to the left. And we are going to use a parenthesis to identify that, saying that it cannot touch negative infinity. Negative infinity is not a real definable point. It's a concept. I mean, just keeps going, keeps getting smaller and smaller. And it's going to stop increasing when I get to my vertex, and my vertex is at 2, 1. And so remember, when we're talking about intervals, we're talking about that x values. So from negative infinity to 2, and we're going to use a parenthesis because at 2 it's neither increasing or decreasing. It's hard to see, but kind of at 2 there's this little flat point. It's neither increasing or decreasing at that point. Now it's decreasing. Well, that's at the top of the hill, right where my vertex is. So it's going to start at 2 and go to infinity. So I really like to think of that hill analogy as I'm walking up the hill, I'm increasing, I'm falling down the hill, I'm decreasing. Okay, different forms of quadratics. So all quadratics have certain things in common. They all have input values, which we describe as our x values. They all have output values, which is my y values. So in every equation, there is an a. This is called the leading coefficient. Okay. Now this leading coefficient, this determines if the graph is positive or negative. Okay, so these are some important things that you probably want to have in your notes. So each form of the equation emphasizes something different. The standard form, this emphasizes the y-intercept. My vertex form, which is my favorite form, I think, emphasizes the vertex of the parabola. I feel like it's the most useful. And lastly, my factored form, it emphasizes the zeros of the quadratic, and we will be doing lots of stuff with zeros. The end of Unit 1 and a lot with Unit 2. Okay, so factored form, or actually Unit 2 and Unit 3 will be a lot of the stuff with the factored form of quadratics. Okay, so let's look at these. So in the quadratic form, my standard form, I have a f of x equals ax squared plus bx plus c. Notice there's my a. The a is going to be very important here in a little bit. My factored form, a multiplied by the quantity of x minus r1 times x minus r2. We're going to learn that these r's are going to help us find our zeros. In vertex form, there's that a again, and that's going to help us determine some things that we're leading up to. A times x minus h squared plus k. Just a little sneak preview here. This is going to be the vertex of the parabola. We're going to say the vertex is h, comma, k. Notice negative h here, positive h down here. Okay. Alright, so the leading coefficient will tell us if a parabola is positive or negative. That's why that leading coefficient is positive. So parabola is positive if the leading coefficient is positive. Okay, and then any positive leading coefficient, any positive parabola will be upwards. So we would say this has a positive a value, or we could say a positive leading coefficient. Okay, if a parabola is negative, the leading coefficient is also going to be negative, just like that. Okay, so let's look. Now you try it. Look at this problem. Will the following graph have a positive or negative leading coefficient of A? So I like to think of this too is positive people have a good influence on me. I'm usually smiling when I see a positive person. A negative person is going to cause me to frown. I look at this frowny face parabola. It's going to cause me to frown. So I know that A has to be negative. Okay? Alright, using vertex form. So the vertex form allows us to easily see the vertex of the parabola. So we talked about a lot of these. So A is equal to the leading coefficient. H is the x value of the vertex. K is the y value of the vertex. We said the vertex is at HK. Okay, so let's see how we're going to use this. So find the vertex of the following equations. So if I notice right here, there's my H value. There's my K value. And there's my A value. So just by this, we can tell a lot of things. We know that one, it's positive. I know it did not ask us to determine if it's positive or negative yet, but we're going to. It's positive. My H is negative 5, so that means it's always going to be opposite, 5, and K is 6. That's my Y value. So remember, the the H value in my vertex is going to be opposite whatever it shows inside. Once we start getting these parentheses and squaring stuff, things get a little bit different. That squared changes a lot of things, so that's why it switches to positive. So we're going to do the same thing over in this problem. We're going to identify. I have my A, my H, and my K. So once again, we know it's positive. H, we know is 4, so we're going to do the opposite. So I know my vertex would be at negative 4, and my y-intercept, or my y value of the vertex is going to stay exactly the same at negative 7. It's as simple as that. Okay, finding intercepts. Okay, x and y intercepts are important key components of quadratic functions. So we can find these intercepts when you're only given the equation. So if you only have the equation, you can still find this. To find the y-intercepts, we're going to set x equal to 0 and solve for y. So y-intercepts are, where does it cross this y-axis right here? So we can see it crosses somewhere right there. The reason that we set x is to 0 because this is when all along this axis x is 0. So if we use that same logic to find the x-axis, I'm going to send the y's to 0 and then solve for x. So there's my x-intercepts right there. Alright, so find the x and y intercept. Okay, so if I want to, so f of x, remember this is just a fancy way to say y. Okay, so if I want to find the y-intercept of this equation, I'm going to substitute 0 into anywhere that I see x. So I have y equals 13 times 0 squared minus 26 times 0. Okay? 0 squared is 0. 0 times 13 is also 0. Minus 26 times 0 is 0. So we know my y-intercept is at 0. So it's going to be, let's think in the x coordinate of that point. So it's going to be at 0, 0. I'm going to say it's at the vertex point. I mean, not the vertex point, but 0, 0, that's my coordinate point for that y-intercept. Alright, and then to solve for my x-intercept is when y is 0, so I'm going to say 0 equals 13x squared minus 26x. Okay, perfect. So now I need to solve for x. This is going to look kind of funky. You guys haven't seen this type of an equation too much yet. We're going to see a lot of it in the coming weeks and months. So notice that in both of these equations, I have an x in both terms of the equation because I have two terms. Remember, terms are separated by addition and subtraction. So what we can do is we can do something called factoring out an x. Factoring is the opposite of distribution, and we're going to talk about that some more. So I have 13x minus 26. Notice, if I were to distribute this x back into the equation, I would get to the step above me, that 13x squared minus 26x. X times 13x is 13x squared, and x times negative 26 would give you a negative 26x. Okay, now that I have this, I can really separate this into two separate parts. I can say what makes this part 0 and what makes this part 0, because I need each of them. If one of them is 0, when they multiply against the other part, it has to be 0 as well. Okay, so for this one, I have 0 equals x, and I have 0 equals 13x minus 26. Well, we have one of my answers right there. X is going to be 0. My other answer, 0 equals 13x minus 26, we can solve for. We're going to add 26 to both sides here. We get 26 equals 13x. We're going to divide both sides by 13. We get 2 equals x. Okay, so if you have any questions about that, please come and check with me, alright? Alright, let's move on. Now I want you to try find the intercepts of the following equation. So once again, we're going to start. We're going to say y equals 5 times 0 squared minus 20 times 0. Now I set my x values as 0, so that must mean that I'm trying to find my y-intercept where it crosses that y-axis. So we get y equals 0 squared is 0, 0 times 5 is 0, and 20 times 0 is 0 as well. So once again, my y-intercept is at 0, 0. Okay. Now we're going to go for that x-intercept. So I'm going to say 0 equals 5x squared minus 20x. Once again, we have to factor out that x. So I'm going to say x. If I take out an x from this first term, I get a 5x left. If I factor out an x from that negative 20x, I'm left with a negative 20. Okay. We're going to set each one of those components equal to 0. Okay. So I get 0 equals x, so that's one of them. And the next one we're going to add 20 to both sides. We get 20 equals 5x. Then we're going to divide by 5. We get 4 is equal to x. So I wrote the coordinate point over here. Let's write it over here. So we're going to have 0, 0, which makes sense because my x and y intercept, if it's at 0, 0, that's going to be the same. It's that origin point. And for the second point, it's going to be at when x is 4 and y is 0. There would be the other x-intercept. Okay? Alright. Let's move on. So finding the y-intercept. Another way to find the y-intercept is to find the constant in the equation. So notice right here, we're in standard form. This is the big thing that standard form helps us do, is it helps us identify that y-intercept. Okay? So let's see. We can see this constant right here. Let's see how if I plug in 0 for my x value. So I get y equals 2 times 0 squared minus 6 times 0 plus 7. Okay? Y is equal to 0 squared is 0 times 2, still 0. Negative 6 times 0 is still 0 plus 7. This simplifies to y equals 7. And my vertex, or not my vertex, my y-intercept is when x is 0, y is 7. That is where it will show on my coordinate plane. So notice that any term that has an x in it, and I set it equal to 0, those terms just kind of go away, because anything multiplied by 0 is 0. And then we add 7 to that term. Okay, so if I have the graph and I'm looking for a y-intercept, I'm simply looking for where it crosses the y-axis, and we see that is right there. Okay, now let's do the same thing with the equation. Oh, there's an x, there's an x. We know those are going to turn to 0. I know that it's going to be at 0, 8. And over on the graph, it's at 0, 7. Both of those are fairly easily once I see. Now remember, this one, my equation, those will turn to 0. Both those x's, so 8's the only thing I have left. In the graph, we can simply see where does it cross that y-axis. Okay, finding end behavior. Now this is it's written really complicated, but it's not a super difficult concept. So it's important to know what's happening at either end of each of the graphs. We want to know what's happening when I move really, really far to the right and when I move really, really far to the left. What's happening at the very tippy tips of the my graphs. Okay, so we want to know what's happening when x gets really big, when it approaches positive infinity, and when x gets really small, when it approaches negative infinity. We state this like this. As x approaches infinity, f of x approaches blank. So what that really means is I'm moving to the right on the graph. So as I'm moving to the right on the graph, what's happening to the graph? Is it going upwards or downwards? Okay. Same thing with the next one. As x is approaching negative infinity, f of x is approaching what? As I'm moving to the left on the graph, this is the graph going upwards, downwards, what's happening to it? Okay, so we want to find the end behavior of this following graph. Okay, so we're going to state it like this. As x is approaching infinity, as I'm moving to the right on the graph, as I'm getting really, really far to the right, f of x is approaching what? What's happening as I move to the right? We can see the graph continues to go upwards, right? So we say it's approaching infinity. Now, when I'm doing my next line, I'm saying as I move to the left, and we say that as x is approaching negative infinity, I also notice that as I move really to the far to the left, we see the graph is continuing upward. So we say f of x is also approaching infinity. Notice on these quadratics, they're both going the same direction. So I should see this f of x, they should both be going up towards infinity. Okay, domain and range. You guys have done domain and range for a few years now, so this shouldn't be an entirely new concept. Okay, so the domain is the x values that exist on a graph. Okay, so remember, as we read graphs, we read them from the left to the right. To find the domain, we find the smallest x value and the largest x value. Make sure the graph does not have any holes or gaps. That is super important. Make sure. Okay, the y values tell me the domain, or tell me the range. So the y values are the range. Same thing, so we find the range from the graph. We'll read the graph from the bottom to the top. Notice we always go from negative to positive here. We're going to find the smallest y value and the largest y value. Also, we have to make sure there's no holes or gaps here. Okay, so if I find the domain and range, so my domain, I'm starting from left to right. I don't see any holes, so we'd say from negative infinity to infinity, and I would use parentheses there. Okay, my range, same thing. I'm going to start from the bottom, move to the top. Don't see any holes. I would say from negative infinity to infinity as well. All of that's all good. Okay, my axis of symmetry. So we know that all quadratics are symmetrical. This means they all have an imaginary line that splits the quadratic into two equal parts that mirror each other. So this imaginary line is called the axis of symmetry. The axis of symmetry is a vertical line that goes through the vertex of the parabola. That's why that vertex is so powerful. We'll go over that in a little bit. So we see it's right here. We see it goes through the vertex. That vertex cuts a parabola in half. So one of the things we know now is that all quadratics are symmetrical across that vertex. So find the symmetry of this line. I find my vertex right here. There is my line of symmetry. So I would say x equals 2. Meaning that no matter what the y value is, x will always be 2. That's how we distinguish a vertical line. Okay, vertical line was always going to start out with x, and there's my axis of symmetry. Okay, so we can use quadratics to problem solve. So we can also use what we have learned about key features of quadratics to help us solve real life situations. Quadratics help us find the minimums and maximums of different situations. Remember, the minimum and maximum values are called the vertex of a quadratic. Okay. So find the maximum height of the following situation. A rocket is shot up into the air that is modeled by the function f of x equals negative 16t squared plus 120t. Sorry, my classroom lights all just went out. It went dark. I need to get some light in here. Okay, I'm just going to write down this equation on a sticky note so I can input it. I'm going to show you how to do this in a calculator. If you look at my updated PowerPoints, I have the calculator instructions for the TI Inspire, which is, it's a lot simpler to do this, and I'm going to show you on the TI Inspire app. Calculator app right now. Okay, so we're going to switch over. Look at my wonderful family right there. We're going to go to the TI Inspire app. Okay, so this is going to be the same type of basic thing that you'll see on your TI Inspire. We are going to graph something here. In my equation, I'm going to type negative 16. We're going to use x. We don't have to worry about that t. squared plus 120 x. Okay, so we're going to hit enter. So we notice I can't see it. I'm going to zoom out here. Alright, so what I'm going to do is I'm going to change this value. Change my window here. See if I remember. There we go. If I notice, I'm going to keep coming up. I want that to go to 100. We still need to go higher. Let's go 200. Still higher. 250. There we go. Okay. And my bottom point here, we're going to say it's -10. Alright, so we can see a nice picture of my parabola. I just had to get a nice window view here for us. So what we want to do right now is we want to find that maximum point. We want to see where is this maximum. So I'm going to come over and I want to analyze the graph. This little toolbar is going to be like your menu button on the TI Inspire. So I'd hit that menu button and I want to analyze the graph, and we want to find a maximum. So what I'm going to do, I'm going to set it right there, and I see that my maximum is at 3.75 and at the height of 225. So really what this means is at 3.75 seconds I will hit the maximum value of that rocket, and that maximum height is going to be 225 feet. Okay. Another way to find the vertex is to use the equation x equals -b divided by 2a to find the x value of the vertex, and that a and b come from the standard equation of ax squared plus bx plus c. So in this case, my a is connected to my squared term, so there's my a, 120 is my b, my c is not just gone, it's just 0. Okay, so to find the x value, so I have to do a couple steps here. I have to first find the x value. So I'd say -b, so I'd say -120 divided by 2a, so it'd be 2 times the -16. I'd get -120. 2 times -16 is -32. My negatives cancel out. Get 120 divided by 320, or by 32. Let's see. It's going to go 3 times. So 32 times 3 gives me a 6. That gives me 96. Okay. We have to do some borrowing here. We get 4. We get 24. So this is where we get that 3 point, and we can do this with a calculator. That's why that graphing part is going to be so important. So just a quick rundown. I just want to talk about why we like that vertex so much. So one, it told us the line of symmetry. 2, it helps us see where it's increasing and decreasing. It gave us that kind of defining point where it switched. And then we're going to see some other stuff. Oh, it also tells us max and mins, maximums and minimums. So that vertex point is super important. I hope you enjoyed this lesson. If you have questions, please come and seek me out or a tutor. We are always happy to help you in whatever you need. Thanks.